Okay, guys, as for homework part 3, first question is a student wishes to check the upper and lower limit of a thermometer. So which two beakers would he need? Now, as you know that the upper and the lower limits should be ice and steam. So not salt, it has to be pure ice. So they have to be beakers Q and S, so the answer is D. As for question 2, it's asking you how can the thermometer be made more sensitive? So it's either by increasing the volume of the bulb or by reducing the diameter of the tube. So you have to read through the options. So the first one is obviously wrong. Second one is correct. So the answer is B. C will only increase the range, not the sensitivity. And increasing the thickness will make it less responsive, not more sensitive. If you go through the presentations, then you should know that the two things that affect sensitivity is the bulb and the diameter, so the answer here is C. So here it's showing you a thermometer that is linear, and if at 0 it's at a length of 2 centimeters and at 100 it's 26, that means halfway between them should be, so it has to be halfway between them, so it's C, 14, because the difference between them is 24. And if you have that 24, it's 12. But 12 plus 2 will give you 14. Or you take the average of 2 and 26. Now the idea with question 5 is that the fixed points never change. So the lower point will always be 0 and the upper point will always be 100 no matter what thermometer you're using. So it's always 0 and 100, so the answer is C. Now for question 6, you need to know what linear means. From the presentation, it means that the length is increasing, is directly proportional to the temperature. So the length increases incrementally as the temperature increases. Check the mark scheme if you need to know exactly what you're supposed to write. Now here, the question is telling you that the range is 120 Celsius. The highest temperature is 110. That means the lowest temperature has to be -10. And then it's telling you how can you increase the sensitivity, obviously by increasing the bulb and reducing the diameter. Please check the mark scheme if there are other options that you could use, but these are the ones that I've given you. Alright, here you're supposed to define what a range is, define linearity, define sensitivity, check the mark scheme if you need the technical terminologies. I have a complete video regarding a thermometer and how to draw it, so. Alright, now for this question, if you open the mark scheme, you might not understand the first point, so you can just ignore the first point because we still didn't take the heat capacity, so you can ignore that one. But basically, as you know, the smaller the object, the quicker it will reach a certain temperature, the easier it will be to heat it up. We will be discussing that further in part 4. But for now, you can say that the thermocouple heats up quickly is because it doesn't really require that much time compared to a thermometer, a liquid and glass thermometer, because the mass is less. But don't worry if you haven't answered this question, it's because you don't really, we haven't reached that part yet. So here for question 8, you have to describe how the thermocouple could be used to measure the temperature of a beaker of hot water. And then you have to state 2 situations where a thermocouple could be a good choice to measure the temperature. So there are 4 marks. That means 2 marks for the description and then 2 marks for each situation. The situations, I've given you the advantages of using a thermocouple. So whenever you need to measure a really high temperature or a really low temperature, the range is really good. Whenever you need to measure something where the response has to be high, so you can look at the advantages of thermocouple from the previous presentation, or you can look up the mark scheme for this question. You can see all the options that you can use for this question. Now for the description, you're supposed to put the beaker of hot water in the hot junction. You have to know the temperature in the cold junction. You have to have the thermocouple calibrated. Whatever reading you have from the galvanometer in millivolts, you have to know what does that translate in temperature, how you can make sense of the millivolt and change it to degrees Celsius, and then you can then add whatever value you have for the cold junction, add the difference, and you'll get the temperature of the hot water. Okay, as for this one, again, I suggest that you check with the mark scheme because there's more than one option, I think. So which one of these is affected by the length? I think the most obvious one is range, but you could also maybe talk about linearity. It depends on how you justify your answer. But range, the longer it is, the higher the temperature that you can measure, and hence a larger range. And then which property is affected by the diameter? Again, what comes to mind very easily is the sensitivity. The smaller the diameter, the higher the sensitivity. You can say that the change in volume now is reflected more in the height. Again, check the mark scheme. Okay, now for this one, write down which liquid would be suitable. Obviously, the alcohol. Give 2 reasons for your answer. You can say that the alcohol now is colored, so it's easier to see. But you can also say that the alcohol can be more linear in changing in size. You can say that it's more sensitive to temperature change. You can say it has a bigger range. You can say that the range is better because alcohol can go up down to -10, whereas water will freeze. Yeah, again, check the mark scheme if you want more options.